If the universe is 13.8 billion years, as you said before, how is it that the diameter of the observable universe is more than 13.8 billion light years? I think that must be an extrapolation because we could not see the universe as being more than 13.8 billion light years in diameter. I think it's 93, I have noted here, but isn't that an extrapolation of what we expect the current location of the galaxies to be on in relation to the speed and expected increase in the speed at which they are separating, that we can conceive it as being 93 billion light years across when the universe is itself only 13.8 billion years?
Right. Yeah, exactly. So we know that the universe is perfectly capable of expanding faster than the speed of light. And we have a model, we have an understanding of the history of expansion of the universe. We can get at this through theory, and we can also get at it through direct observation. So if we look at a distant galaxy at the edge of the observable universe, we can measure directly how quickly it is receding away from us at this very moment, or at the moment when the light left that galaxy. And then we can look at all the galaxies between us and that distant edge and see how quickly they are receding away from us. And from there, we can build up a map of the expansion history of the universe. And that's how we are able to get the total size of the universe. It's like sampling a bunch of cars on a freeway with how fast they are going. And by measuring how quickly they're going, you can get the total length of the road. And so we know that our universe is about 93 to 95 billion light years across, even though it has only existed for 13.8 billion years.
You have an analogy in your book, Your Place in the Universe, to represent the hugeness, the absolute mind-bogglingly hugeness of the universe. In this part, you only talk about the galaxy, but I will read it to the audience just so they can hear it. Were you to put the Earth a scant 3 feet away from the Sun, in an analogy, Proxima Centauri would be 200 miles away. The Milky Way galaxy itself is around 100,000 light years across. Simple math reveals that you could fit 25,000 sun-Proxima distances across its breadth. In our scale model, with the Sun 3 feet away from Earth and Proxima 200 miles away from that, the Milky Way in its entirety would stretch 5 million miles, which would put the edge about 20 times farther than the Moon. I think this is just mind-bogglingly. I don't know how big the Milky Way is in relationship to the absolute universe. What's exactly the percentage that our Milky Way, maybe you don't know the exact number, but the Milky Way, I think it's 105,000 light years across, if I didn't get that number wrong. And the universe is, as you said, 93 billion light years across. So that percentage, it's just so mind-bogglingly big.
Oh yeah, the universe is gigantic. We can write down numbers for it, but trying to express it, I come up short every single time.
It's amazing. When I read that in your book, Your Place in the Universe, that you put the Sun 3 feet away the Earth in a three-dimensional representation here on Earth, Proxima Centauri would be 200 miles away.
Yeah, it's crazy. Space is big, and it's bigger than we can possibly imagine. It's bigger than we can really comprehend. We're almost used to talking about solar system scales by now, of sending spacecraft, and it will take the better part of a decade to reach the outer solar system. We're used to talking on those length scales. But going anything beyond our solar system, it just doesn't make sense.